Hi everybody, this is Parker Wagner here, and I recently wrote a terrain generator program using OpenGL, and I wanted to talk about that and show you guys what I was able to come up with here today. So I wrote a terrain generator using an algorithm called the Diamond-Sqaure algorithm, and the Diamond-Sqaure works basically this way. So this is from the Wikipedia page on the Diamond-Sqaure algorithm. And so what you're going to do is you need to create a field of vertices, and the dimension of this vertex field, it's going to be expressible in the form 2 to the n plus 1, because that ensures that for every set of corner vertices that you're going to run this algorithm on, there will always be a central vertex there. So as you can see in this example, you have these 4 corners here, and it's going to perform the diamond step on this middle vertex here. And as you can see by the illustration, it does this. So I'm going to walk you through how the algorithm works here. So you have your field of vertices, as you can see in each of these steps, and how it's going to work is the yellow vertices are going to be the ones that are being modified in the step. The white, or clear colored, I guess, vertices are going to be the ones that are not yet valued. And then the black ones are going to be the ones that have a value already at that given step. So how this algorithm works is you initialize your 4 corner vertices to be heights that are within a certain range. All right, and this range is going to be important here, and I'll explain why in a second. So you have these 4 initialized, and then what you're going to do is you're going to perform the diamond step, which is for each square in your array, you're going to set the midpoint of that square to be the average of the 4 corner points plus a random value within that range. Now, what you can do is, these pictures are great because you can see which values are being used to influence the values that are being set, because they have these little convenient arrows here. So you're going to take the average of these 4 here, and then you're going to add to that a value within a range, and for every step into the algorithm, what you're going to do is you're going to attenuate the value of this range, so that whenever you're initializing your vertices here, the range is very big, and then as you progress into the algorithm, well, I did it recursively, you can attenuate the bounding of that range so as to make your values not vary so much as they're getting closer and closer together. So what you're going to do is you're going to take average of these 4 plus the value in the range, set this vertex here, and then now you can see that divides the field into 4 other boxes here, this one and this one here. So what you're going to do is you're going to say, okay, I'm going to run the square step. So for each diamond in the array, you're going to set the midpoint of that diamond to be the average of the 4 corners plus a random value. So you're going to take this here, and you're going to say, okay, so I have these outermost vertices here on the edge. And because this is actually an issue that I came across in implementation, there isn't like a 4th vertex up here or down here, as you can see. And there are a couple ways you can work around this. The first of which is that you could like wrap the vertex around, so as like effectively there would be another vertex out here, but you're going to pull the value from the other side, so it'll just come around. And then the other way you can do it is you can just take the average of the 3. I opted for the average of the 3 approach, excuse me, just because it was easier to work around in implementation. So in this step here, the square step, you're going to take the average of these 3 plus a value in the reduced range. Note that that range is reduced. Store it here, and then do the same thing here and here. And then now you've got your 4 squares. Then you run the diamond step again, but instead of it being this big triangle, or not big triangle, big square here, you've got 4 little squares. And because of the nature of how this program runs, it's a pretty good fit for recursion, and that is exactly what I was able to do. And the output of something like this is you get some terrain that looks like this. It's got kind of a plasma effect. That was how that was achieved. I actually wrote kind of a little testing suite when I was just working on getting my values for my height map. And what it did was the X and Z positions are fixated because it's a plane, just a 2D plane across the XZ plane. And then I put in a height map, which was a 2D array of floats. And this height map is what OpenGL would pull as the Y value when it was doing the terrain render. So what I did was I wrote the Diamond-Sqaure and got it to work by populating that height map with values that I would generate using that recursive algorithm. And then this was the kind of terrain I got, and I was like, okay, cool. But terrain's pretty lame when it is just completely gray. Even though wireframe's kind of cool, it doesn't really have much of an effect. So what I did after that was I went through and I added colors. And the coloration was pretty neat. What I did was I went through, and after I had calculated the height map, I stored the range of heights that were within this height map, like the lowest possible height that was created and then the highest point. And then using this kind of range here with values, I was able to generate a function, I wrote a function that calculated for each triangle. So the triangles that are rendered, as you can see here, have 3 points, and I would calculate the average height of the points of the triangle, so the triangle height, and I would say, okay, my triangle is this high, what percentile of all triangles in the scene is this triangle? And then based on whatever percentile I got back, I would color it accordingly. So for example, I think I set anything that was like the bottom 20% of all height values, I would clip it up to be flat because I wanted it to be water. And I would color it accordingly. And then anything, like it just kind of tiered up from there. I put in like little beach colored, like some sand around there. And then as you got up, it was like some pretty live grass here. And then you get your more mountainous grasses. And then finally, once you get to like the top 10%, 10, 12, 15, somewhere in there, you get kind of like your snow-capped peaks. And yeah, so that was how I went about that. And okay, so yeah, this was kind of like this is like finally what I ended up with in terms of like a wireframe render, but that's pretty boring. So I've got it up here, and we're gonna kind of get to fly around a little bit and kind of show you what it looks like. I'll make this a little bit bigger for some better visibility. All right, so right now it's wireframe and fill. If I take out the fill, you can see like how all of the triangles interact and make this. I'm currently up above like the highest point in the entire thing because I'm by the snow peaks. But if I want to move wrong direction, this way, you can kind of get down to where this grasslands start to happen down here, and then you can see the water is flat down there. I'll turn it. Oh, it doesn't want to cooperate with me, but I'll use this look Z vector here to spin us around, and you can get a better idea of how it looks. Oh, also, I wanted to forego the traditional like daylight skybox because I didn't want to be conventional, and I wanted to add something a little bit different. So I took a picture that I found online that was like, it was like a high definition resolution black and white rendering of some like stars and stuff, right? And I took it into GIMP and I ran it through with a converter into a PPM, and then I used some files from the lab, the Mario lab, and I was able to do texture mapping from the PPM onto just a plane. And then once I had the plane, it was pretty trivial to get the skybox up. Yeah, and I thought that added kind of a cool effect to that. Let's see, what else do I want to talk about here? Yeah, so I guess I can take you through just a little bit of the implementation. Just close out some of these. I don't need to. Okay, So I wrote, as you can see in this project, we had cylinder.h, shape.h, sphere.h, cone.h. So fittingly, whenever I wanted to write my terrain, I wrote a terrain.h, and I defined my dimension to be 1025 because, as I mentioned earlier, you want your dimensions of your array of points to be a 2 to the n plus 1. So 1024 being a power of 2, I added the 1 to get 1025. And then once we get into here, I had initially all of the terrain generation calls and stuff in the constructor, but I wanted to be able to write a regenerate button onto my GLUI thing, so whenever you clicked it, it would rerun it. And I was getting some weird shenanigans whenever I would just have it there, primarily some memory stuff, and I decided why not just throw it into a generate function, and then terrain constructor can just call the generate, and then I can write a callback with a button that'll just call the generate method on my object. And that's what I did. So let's see here. Yeah, so as I mentioned earlier, things were done with percentiles in terms of coloring. So yeah, sorry, got text. Yeah, so I wrote two separate functions, one to draw the filled triangles, one to draw the filled frame. Yeah, I want to get to, yeah, here it is. So my calculate Diamond-Sqaure height map. So what I passed into this was a top left vertex, top left x value index in the height map, a bottom right vertex x value location in my height map, and then for the y value is the same thing. And then I put in a depth argument here, and this was important in how I did some of the attenuation of the possible range of values that I could get. Yeah, so how you control the recursion here is basically you do the recursive steps until you get to like this point here, where you would then, like the next step if you got to here would be to call the diamond step on these four, but as you can see there's not another defined vertex in the middle there, so you need to bottom out. So I did this by saying I want my current length of my square that I'm doing the diamond step for to be my bottom right x minus my top left x, and if it was short enough that there wasn't going to be a defined point there, then I'm just going to return out, just returns void. So yeah, then to calculate where in the height map I'm going to be modifying on the square, I just took an average. Initially, my max threshold of my range was going to be 100, and then I attenuated this by, for every level of the depth, I would take this multiplier and I would multiply it again by the value 0.8. And this turned out to be a pretty fitting attenuation for the ranges there. I even, in between the diamond step and the square step, I took it out again. Just to kind of, it ended up producing more of a smooth terrain the more you lessened the threshold for the values. So yeah, I had the indices that I was going to modify. I calculated my random value. I introduced the average height. So I said the height map at the position being modified equaled the random value plus the average height of the four bounded vertices. And then after that, I go to the square step. I increase my depth, attenuate the range some more, and then I set the four vertices here. I just took the average of 3, like I mentioned before, because I didn't want to do the wrapping. And then after that, I've done the diamond step and the square step. So then I'm here, and I know all of these positions, so I just call the method again, like the whole function, but I pass in this is my top left point, this is my bottom right, this top left, this bottom right, this top left, this bottom right, and then this top left, this bottom right. And I, of course, put in depth plus 1. and that populates the height map. So yeah, and then OpenGL took care of all of the rendering for me, and that was really great. And yeah, this kind of concludes that presentation. One issue with the Diamond-Sqaure algorithm that I encountered, I found this, like, I had noticed this behavior and I was like, this is so weird, what's going on? And then I had this page up because it was really better for me to visualize how this algorithm was working with these pictures here. But then I saw this and I said, okay, this kind of described the behavior I was having. It says, it was analyzed by Gavin S.P. Miller at SIGGRAPH in '86, and he said that the algorithm's flawed because it produces these noticeable vertical and horizontal creases through your terrain, and that's got something to do with how it segments off the entirety of the, like, 3/4 of the terrain after every Diamond-Sqaure step. So, like, you have all of this over here, but these values are being, whatever you call it recursively here, it kind of puts itself into a little vacuum, and the values that come out of all of the calculations that happen after this point don't take into account any sort of, like, averages of what happens over here. And so along these, like, main creases here, you'll get kind of some ridging behavior. I mean, you could try to come up with a way to fix it. You could just kind of color it differently, make it look kind of like a canyon, make it look intentional. But I just wanted to leave it because I want to continue to work on this in the future and maybe come up with a way to work around that. So thank you very much for watching this presentation. I would highly recommend that anybody take a stab at implementing the Diamond-Sqaure algorithm. It was really fun to work through. It was really good fit for recursion. I greatly enjoyed thinking through it, especially if you happen to have a terrain render that has a height map already and it's rendering off the height map. Just go ahead and try and write the function to Diamond-Sqaure populate the height map, so see what you can come up with. So yeah, thank you very much for watching, and see you later.